In this lesson, we're going to learn about the quadratic formula. So this formula will be a formula that you'll be expected to have memorized throughout this unit and beyond. And at the end of the lesson, I'll give you a link that you can watch a video for that will really help you memorize this formula. So don't be too intimidated by the fact that you'll need to learn it. So when your quadratic equation that you're solving for is prime, meaning it cannot be factored using your factoring methods, you will be able to, after this day, use the quadratic formula to help you find the roots. So remember, we've talked about just because your quadratic is prime does not mean it can't be graphed or that it doesn't have roots. That just means that its roots are not nice, clean numbers like integers or nice fractions. So when this occurs, we'll be able to use the quadratic formula. And here it is. This is the quadratic formula. X equals negative b plus or minus. So we'll do it one time with a plus and a second time with a minus, because remember, we often have two roots. So negative b plus or minus the square root of b squared minus 4ac all over 2a, or divided by 2a. Remember that a, b, and c all come from your standard form of the quadratic equation. So standard form is ax squared plus bx plus c. So whatever numbers are in these places, that's where our numbers will fill into our quadratic formula from. So to use the quadratic formula, we need our equations set equal to 0, or really what this means is you need them in standard form of ax squared plus bx plus c. Then you will substitute your values of a, b, and c into your formula and simplify. And you'll state your two answers, one using an addition sign and one using subtraction, since we'll do plus or minus. So here's our first example. We have 4x squared minus 3x equals 2. So this equation is not in standard form because it's not set equal to 0. So you will need to start by setting the equation equal to 0 by subtracting 2 from both sides. This gives you 4x squared minus 3x minus 2 equals 0. From this point right here, I recommend coming off to the side and stating what a, b, and c's values are. In this case, a, the number times x squared, is 4. B, the number times x to the first, is a negative 3. And c, the constant at the end, is a negative 2. Do this, and then you won't really have to look back at your starting equation anymore. This will also make sure that you are paying attention to negative signs, which will be very important here. Okay, so from here we're going to fill into the formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So all we do is anytime we replace a value, we put parentheses around it. So the negative b portion looks like negative, and then parentheses whatever b's value was. In this case, negative 3. So I see two negative signs next to each other. That's okay. That will turn into a positive. Then your plus or minus sign, the square root of b, again, use parentheses, squared minus 4, always 4, times a, in this case, which is also 4, c, which in this case is negative 2, all over 2 times a, or 4. So I just replaced a, b, and c with their corresponding positions or spots in the formula. From here, in the work I want you to show for this, I want you to think about your quadratic equation as 3 chunks. So we've got what I call chunk 1, chunk 2, and chunk 3. And I want you to simplify each of these 3 chunks separately. So first we'll get negative b to be positive 3. Plus or minus, well, here we've got negative 3 squared, which is 9, minus 4 times negative 2. So if I'm simplifying this, I've got 9, and then negative 4 times 4 is negative 16, times a negative 2 will be plus 32. So that's how we get this chunk to be 41, a positive 41, and then 8. And, if you want to use your calculator and type in exactly what you see here with parentheses, because that will be very important with negative signs, into your calculator to get this 41, that is okay. But on your paper, you should clearly show this step 3 as I've shown it here, with chunk 1 simplified plus or minus chunk 2 under the radical all over whatever 2a simplifies to. After you've done this, you may want to use your calculator to approximate your values for x. So let's hop over to our calculator. So we've got 3 plus or minus the square root of 41 all over 8. So remember, this is going to give us our two roots. One time we'll be adding, and the second time to get the other root we'll be subtracting. So I'm going to use my division symbol, control division, and then type my 3 plus the square root of 41, 41, all over 8, arrow out, and hit enter. That gives you your first root, which, remember, with our roots, the y value is 0. We were setting it equal to 0 right from the beginning. That's our y value for the roots. And then, so that gives us the first root as, let's see, what do we get? Approximately 1.17, 0. Then, and this is where you'll want to copy and paste this 3 chunks simplified expression you have here. Bring it down so you don't have to retype all of that, and then just arrow back into it and edit your plus sign to be a subtraction sign. And once you do that, hit enter, and you get your other root. So here we get our other root to be about negative 0.42 something. So these are approximately your two roots, which can be written as 2 points, 1.20 and negative 0.40. If you are graphing, which do I have that next? Okay, well, if you are graphing using these roots, remember you would plot your roots. Let's say I've got 1.20 here and negative 0.40 about right there. You would then finish by finding your vertex. In this case, because a is positive, the vertex is going to be somewhere down here. So vertex you would find by doing your x equals negative b over 2a, get the x, substitute in, solve for the y, then you get your ordered pair for the vertex, and you can graph your parabola. But here we're just today focused on getting the actual roots. The whole graphing piece you can do on your own. We've done several lessons now on graphing. So our roots are approximately 1.20 and negative 0.40. We'll round to tenths or hundredths for this lesson. Okay, here's your next example, practicing using the quadratic formula. So here we have 24x squared minus 14x equals 6. It is not in standard form, so you do need to start by subtracting 6 from both sides. Now, from here, you would look to see if it could factor, remember. And in this case, there is a GCF. However, if when you pull out that GCF, your first step of factoring, if what you are left with cannot be factored further, then unfortunately the GCF in this case does not help you with solving for x. So here I have a note that if the GCF does not help you factor further and what you're left with inside is prime, then just kind of think of this as, oh, it couldn't be factored, which I know is false because a GCF came out of it, but kind of ignore this and come back up to the top and use A, B, and C that were originally given to you. So 24, negative 14, and negative 6. So again, do look if the GCF coming out will help you factor. Look if what's left will factor. If what's left will not go further to break apart the x squared, then it's really not useful to us. We will need the quadratic formula, and we'll use the original A, B, and C. All right, from here, we'll fill in our A, B, and C values to our quadratic formula. So that's what that looks like, parentheses. This step should absolutely be shown on your paper with nothing simplified. When I'm grading, will want to see that you are using parentheses, your negative signs are all in the right place, and you doing this very carefully will ensure that you don't make careless errors in your simplifying from here. Next, go ahead and simplify your 3 chunks to get 14 plus or minus the square root of 772 all over 48. And use your calculator to go ahead and find your true roots, once by adding, once by subtracting. So we can do that one together one more time. So 14 plus the square root, I believe it was 772 all over 48. So one time we do it with addition, scroll back up to copy and paste it, and edit the addition to subtraction. Ooh. There we go. And so your two roots are 0.87 and negative 0.28 or 29. And to graph, that's what you would graph approximately. For your roots, you could then, again, find your vertex using negative b over 2a for x, get your y, and have 3 points to graph this quadratic. Okay. Let's talk about a couple scenarios that can occur when you are finding your roots using the quadratic formula. If you have a negative in this chunk right here, remember I want you doing those 3 chunks, and one of the reasons is so that if you get a negative under this radical, I want you to remember that that is not possible. We cannot take the square root of any negative number. That's technically imaginary. So if that occurs, then this is an example of a parabola that has no possible roots that can be found. So I don't want you to confuse this with it not being able to be graphed. All this represents is a parabola that never hits the x-axis, and that can look a lot of different ways. It just means that your graph never crosses the x-axis. So if you have a negative under your radical, you will then say no roots. And if you were to need to graph it, you would use the table method for graphing. You'd find your vertex, set up your table of x and y values, and plot those points like we did at the very beginning of the unit. Okay, and so that's the end of our lesson using the quadratic formula. There is a video that in class I will show that really is quite silly, but when you watch it several times, you will get this formula so stuck in your head that you'll never forget it ever again. And so if you want to watch that video, it is on YouTube, and it's called the Quadratic Formula video. It's really wacky and tacky, but it works. So go ahead on your own time, search that video, watch it, and practice memorizing your formula. And that is the end of our lesson for today.